Which of the following is false? A. The charge of oxygen in carbon monoxide is -2. B. The oxidation number of oxygen in carbon monoxide is -2. C. The charge of oxygen in magnesium oxide is -2. D. The oxidation number of oxygen in magnesium oxide is -2. By definition, for a monatomic species, the charge and oxidation number are the same. Magnesium oxide is not a molecule, and it is made up of two separate species, a monatomic cation, magnesium 2+, and a monatomic anion, oxygen 2-. Therefore, the charge and oxidation number of oxygen in magnesium oxide are both -2. Choices C and D are true. Strictly speaking, charge is not defined for atoms that are part of polyatomic species, such as molecules or polyatomic ions. Therefore, choice A must be false. The correct answer is choice A. Let's examine choice B to understand why it is true. In a polyatomic species, each atom is assigned a fictitious charge called oxidation number or oxidation state. The basic rules for determining oxidation numbers of atoms in a polyatomic species are as follows. Number 1. Shared electrons belong to the more electronegative atom. Number 2. Ownership of shared electrons is split equally between atoms of the same kind. Fluorine is the most electronegative atom, followed by oxygen. Therefore, if an oxygen atom shares electrons with atoms besides oxygen or fluorine, the oxygen atom ends up being assigned ownership of all shared electrons. As a result, oxygen gets assigned an oxidation number of -2. To understand why, continue watching, but you must already know about how atoms share electrons to appreciate the explanation. Here's the Lewis structure for carbon monoxide. The three lines drawn between carbon and oxygen represent a triple bond, 3 pairs or 6 valence electrons that are shared by the two atoms. Since oxygen is more electronegative, all 6 shared electrons are taken as belonging to oxygen. These 6 plus the lone pair on oxygen gives oxygen 8 valence electrons. If we refer to a periodic table, we find that oxygen belongs to group 6A. A free oxygen atom has only 6 valence electrons. Therefore, it appears that the oxygen atom in carbon monoxide has gained 2 electrons. 6 plus 2 equals 8. Thus, we say that it has an oxidation number of -2. In other words, an oxygen atom that is part of a polyatomic species will generally be assigned ownership of the entire octet of electrons surrounding it, and it will have an oxidation number of -2. The exceptions would be cases where the oxygen atom is sharing electrons with another oxygen atom, or with a fluorine atom which is more electronegative than oxygen. What about carbon? Of all the valence electrons shown here, the carbon atom is assigned ownership of just 2 electrons, the 2 electrons in this lone pair. If we refer to a periodic table, we find that carbon belongs to group 4A. A free carbon atom has 4 valence electrons. Therefore, the carbon atom in the carbon monoxide appears to have lost 2 electrons. 4 minus 2 equals 2. The fictitious charge assigned to it is +2, or we say that its oxidation number is +2. Note that the sum of the oxidation numbers add up to the overall charge of the species. A molecule is neutral, so the overall charge of a carbon monoxide molecule is 0. The oxidation numbers of carbon and oxygen in carbon monoxide are +2 and -2. They add up to 0. Oxidation number is similar to formal charge, which is also a fictitious charge. The main difference between the two is that equal ownership of shared electrons is assumed in determining formal charge, regardless of electronegativities. In carbon monoxide, the formal charges of carbon and oxygen are -1 and +1, respectively.